Hello, I'm Yves.
Hello, I'm Frederic Joe. Our team name is Kinetic Power Systems, and today we want to present our innovative project, an electrical energy generating speed breaker designed for urban energy challenges.
As we all know, rapid urbanization leads to increased demand in more sustainable and reliable sources of energy, especially in cities having unstable power grids. So we have dark cities, power shortages. All these made us come with an idea: how can we power our cities with an alternative source of energy? So we are presenting to you our energy harvesting kinetic power system, which converts a vehicle linear motion into a rotatory motion, thereby transferring its energy into a generator. So this project converts a natural speed bump into a generator. This generator then is going to supply our cities, and why not our country, with a new revolutionary source of energy. Now, how does it function? How are all these main parts connected all together to produce our electricity? So let's start. When we press the speed bump, try and press it please. We have a rack-and-pinion mechanism responsible for converting the linear motion of the speed bump into a rotatory motion. This rotatory motion, since the pinion is too small to produce the expected output at speed, what we are going to do is take a gearbox, that is, convert a certain amount of gears, put them all together to produce a certain gear ratio, which is going to multiply the speed at the output of the generator. Now, this speed at the output of the generator is then producing our electricity. This electricity now is then stored in our battery here, this 12-volt battery, just for a prototype. This generated electricity, which is generated by our generator, is then sent to the 5-volt LEDs to power the LEDs. But since we don't want electricity to be wasted, we introduce an LDR responsible for controlling it's a light sensor responsible for controlling the LED should only be on when the times are dark. But if we just connect the generator to the LDR like this, electricity will still be wasted in such a way that there will be constant flow in electricity even though it will not be used. So we use a 12-volt battery to store the electricity in case of non-usage. So today we are powering 2 LED lights. Tomorrow it can be an entire city. We are powering 2 LED lights with just a small apparatus, just with a gear ratio of 5. What can we do with a gear ratio of 10? What can we do with a better infrastructure? What can we do with a more powerful generator? Let's do a simple test to show you practical results of our innovative project. So, now electricity generated. Now we are going to show you electricity cannot be shown right now because there is a lot of lights. So I'm just going to off the lights. First of all. First thing first, there is a security so that electricity should not be wasted from the battery. So now I'm allowing electricity to flow from the battery to the other apparatus. Now I'm going to off the lights. Due to the fact that light was dimmed, there was no light, the apparatus just extracted electricity from the battery, and the LDR detected no light, so light is provided. So if now I on back the lights, you see for a moment due to the fact that there is light, the LDR sensors detected that we no longer need electricity from the batteries. So this is a simple way to show you how our project functions.
Thank you for joining our journey towards sustainable cities. Together, let's drive innovation, sustainability, and energy independence. Thank you.